Hi everyone. Here is our notes for this particular note set. All right, so let's go ahead and get started. So let's go over a little bit of review of stuff that you may have already seen before. So first of all, remember that thermal energy is the sum of the kinetic and potential energy of particles in an object. Kinetic energy is energy in motion, and potential energy is stored energy. Now, this is going to come back in the spring. We start going over physics because we go over kinetic and potential energy then as well. This relates to matter, specifically how matter physically changes states due to the motion of the particles within it. A theory explains what we know to be true about this, and that theory is the kinetic molecular theory. Excuse me. All right, so all particles are made of smaller particles. Did I say all particles? All matter is made of small particles. So atoms, ions, molecules, anything that is considered super small. Those particles are in constant random motion. And this motion causes the particles to collide with each other and the container that they are in. You need to remember this because you are going to be tested on this on your unit test. 100% this is a question. So you need to make sure you understand and remember this. All right, let's talk about temperature. So temperature is the measure of the average kinetic energy of particles in an object. So the higher the temperature, the higher the kinetic energy, and so therefore the greater the motion of the particles. So you have two questions you're going to be answering in your notes. There's spaces there for you, so you guys can delete those like lines, and you can go ahead and answer these questions. So the first question is, how does this connect to the states of matter like solids, liquids, and gases as far as particle motion? And these are just guesses. I know you guys probably don't know yet, so these are totally just guesses. And then how do you think the motion of the particles differs in each state? So we're going to go through the answers for each of these in the following slides. So go ahead and answer what you think those things are, and then pause, and then come back. All right, let's talk about the three states of matter. So the three states of matter are solid, liquid, and gas. So let's go ahead and break down solid first. So solids are fixed volumes and fixed shapes. So very tightly packed together, rigid structures of particles, just like the pictures you see here. So this is particles in a cube shape, and then this is what they would look like without like the lines there. Particles have a very low kinetic energy when they're in a solid. Because of this, particle motion is limited to just vibration. So we're going to kind of go over some hand movements that go with these to help you better understand. But basically, solids, they just vibrate. So you just with your hands. Liquid is the next one. So it's a fixed volume, but the shape changes based on the container it's in. So for example, this is a cylinder. So those particles are looser. They're kind of moving a little bit more. So particles have more kinetic energy than solids. So the particles can flow or slide past each other. Let's talk about gas. So gases have no fixed volume or shape. If they are confined in a shape, gas particles will spread out to fill the container. This is called diffusion. This is why, like, for example, like smells, when you spray perfume on one end of the room, eventually you'll be able to smell it over on the other side of the room, just because of diffusion. So gases spread to fill a container. Particles have a really high kinetic energy, and the energy is high enough to overcome any forces that hold the particles together. Particles can freely move about. Even in a container, they're confined a little bit, but they still fill to fill that container. There are two other states of matter, but we're not going to be really focusing on them too much, but it is worth mentioning. So plasma is the first one. It's matter composed of positively and negatively charged particles with extremely high kinetic energy. So it's actually the most common form of matter in the universe, and it makes up stars, neon lights, auroras. So that's how you get these really beautiful, views of galaxies and stars and the aurora borealis. The next one is really cool too. They're called Bose-Einstein condensates. These are atoms that are super cooled to such a low temperature, almost absolute zero, that they form a superatom. So this was created by scientists in 1995. All the particles in the superatom are at the same energetic state and will even slow down light that passes through it. So this is used to simulate conditions in a black hole, because obviously we can't just toss things into a black hole and expect them to come back. So this is how they simulate it in a lab. Let's talk about changing of states, so phase changes. So when particles gain or lose thermal energy, they can undergo a state change. So this is a physical change because the identity of the matter is still the same. So an example is when ice melts, it's still water, it's still H2O. It just goes from solid, liquid to gas. Heat of fusion is the amount of energy needed to turn a solid into a liquid at its melting point. So when heat is added to a solid, it has more kinetic energy, so the particles vibrate faster and start moving farther apart as they transition to the liquid state. And then heat of vaporization is the amount of energy needed to turn a liquid into a gas at its boiling point. And I'll show you this on the heat curve that's coming up. So let's go ahead and talk about this diagram. So this is how phase changes happen. So the red arrow means you're adding energy into the system, and the blue arrow means you're removing energy from the system. So let's go ahead and start from solid to liquid. So you are going to have to reproduce this in a test, so be prepared. So we're adding energy when we go from a solid to a liquid. This causes melting. The easiest example to use is water, because it's so unique that it has really nice ways that you can see these phase changes. So going from a solid to a liquid means you're adding energy, and the other way, because you can do that, is called freezing. Now going from a liquid to a gas is called vaporization, and that means you're adding energy. When you take away energy from it, goes from a gas to a liquid, and that's called condensation. So vaporization would be steam, and condensation would be like the stuff you have on a glass, especially when it's warm outside and it's cooler in the glass. You can also have changing states between a gas and a solid. So when you go from a gas directly to a solid, you're removing energy. That's called deposition. And when you're going from a solid to a gas, it's called sublimation. This one's kind of uncommon, but it does happen. So let's keep talking about changing states. So this is a necessary distinction when we're talking about phase changes. So vaporization is the phase or state transition from liquid to gas. It occurs in two different ways. These are important to remember, so please remember. Evaporation is one. It's caused by the pressure change, which occurs only at the surface of a liquid. Evaporation only happens here. And boiling is caused by temperature change, which occurs throughout the liquid. So that's the bubbles that are coming up from the bottom. That's boiling, and evaporation is literally where liquid turns to gas. So this is a heat curve. So this is a base heating curve. I'm not sure what element it is or what compound it is, but because it's not water. All right. So, oh no, it might be water. So heating curve is a diagram that shows the state transitions a substance goes through as heat and energy is added to it. And you can also go backwards. So when energy is taken away. So let's go ahead and break this one down. So this is for the heating curve of water. So here's the solid. So when you go from a solid to the next phase change, which is a liquid, you're going to be melting. And then from a liquid to the next phase, which is gas, you're going to be boiling. There are some different things in between that we've already talked about. So the heat of fusion right here, when you go from a solid to a liquid, and then heat of vaporization when you go from a liquid to a gas. If you guys have any questions, let me know.